Today we are going to talk about how to simulate ISIS adjacency using rtbricks, which is installed on an Ubuntu machine, towards a Juniper, and how to send root updates via ISIS and also try to send incremental root updates. Now you can use rtbricks to scale your routing product, whether Juniper, Cisco, any vendor. You can just connect it in places where you don't have access to Ixia or other protocol testing tools. You can use rtbricks to run ISIS adjacency to push a lot of routes and check the stability of the product that you are testing. Now in the diagram, I am just going to demonstrate on the left part of the topology. I have an rtbricks that is connected to a Juniper box. On the Juniper, the interface is ET003, and on the rtbricks, the interface is ENS20. That's going to emulate ISIS. I've already posted another video on the channel about how to simulate BGP and to send traffic using rtbricks. You can refer to that video. This is a video in addition to that where we work on ISIS simulation and how to generate routes over ISIS. Now quickly jumping into the rtbricks, which is installed on the Ubuntu. So this is my rtbricks. So first what we need is, before we create an ISIS adjacency, we need to create a list of LSPs, pretty much route information that we want to send via that ISIS. Now to generate it, as you install rtbricks, you have these functionalities that is available as packages. One thing is called lspgen. Now lspgen will be able to give me options to simulate the routes that I want. So first let me take lspgen-h. You see the list of options that the lspgen gives me. -A is for area, -p is for protocol. The interesting point is, for protocol, you can simulate LSPs for ISIS, OSPF version 2 or OSPF version 3. In my setup, I'm using ISIS, so I will use protocol ISIS. Of course, you can simulate authentication type. You can also simulate routes like IPv4 prefixes, IPv6, IPv4 node prefixes. A lot of different options are available. If you don't want v6, you just want only v4, you can give this option. If you don't want segment routing, you can give these options. So a whole load of options are available, including external network counts. Now based on these options, I am going to create an lspgen file where I'm calling lspgen-c is an option here to give me the number of nodes that I want to simulate. So I'm just giving 1, but the default is 5. Even if you give 1, it will create 5 nodes. So -m is going to create an mrt file. So this is a file that will be called by the ISIS configuration. Once that configuration calls this file, whatever routes are inside this will be sent out via ISIS towards Juniper. Now -c is just the connector ID. So this is just your local system identifier. I'm just telling the area. I say I don't want IPv6, only v4 routes. For protocol, I'm generating it for ISIS. Likewise, all these options are signifying a particular reason why I've used it, and they're all listed here. In the interest of time, I will just skip to what I want to advertise. So I just want to advertise networks in this range, and I want to advertise the link addresses in this range, and the corresponding external addresses are also listed here. Now the key part is I'm also writing this to a JSON file so I can read it later. Now as you know, the file that is having all the LSPs is called G.mrt. Now let me open up the ISIS config file. So this is the ISIS config file. As we discussed on the topology diagram, ENS20 is the one that connects to Juniper. So ENS20 on the rtbricks has got this address. Its gateway address is the router. Now within the configs, I am also specifying an instance ID for ISIS and the level that this interface is a part of. Now for ISIS configuration, I reference the same instance ID. I give the system ID. So you can remember in the lspgen, I have called that same system ID here, 1001. So it's just a kind of a connector syntax, the router ID, the host name, the area that it is talking, hello padding, and LSP time you can obviously manipulate it according to your needs. So the most important reference to the file which is going to generate routes is the external mrt file, the g.mrt, which is what we have created and stored when we created the lspgen, g.mrt. Now that's what I'm calling here. And the system ID. So how did I get this particular unique value? It's when you run this lspgen command, which I will run and demonstrate, it will tell me what is the root ID. So I'm just taking that command. So let me first remove the old mrt file that I had. So I'm deleting it. Now I'm going to run the lspgen command. As you run it, you can see it's generating the connector, which is just the system ID of the rtbricks. It's generating all the routes what I want as per my requirement fields and flags, and it's telling me the route ID. It's taken it from this address, the node address, and so because it's creating 5 nodes, you can see it's setting the node to 5. So there in the 5 nodes, node 1 is considered the route ID, and that is what I'm calling in the configuration, the route ID. And you can of course send traffic streams to this address because I have 5 addresses that I have in this range. As you can see here, it's telling me 5 prefixes. Among these 5 prefixes, I am sending traffic to one of the prefix. Now, if you remember, we have also stored this file in a JSON, so you can read it to see what is your LSP flood information going to contain. So I'm opening the JSON file. You can see here it's creating 5 nodes, node 5. Likewise, it's got node 4, node 3. Each of them have a list of configs, and it has also got metrics. So if you want to manipulate metrics in your ISIS update, you can update the metrics whatever you like. By default, it is auto generating a few metrics. It's just demonstrated here, and you can play with it. So these 5 nodes are what is going to be sent by ISIS once you start rtbrick. So I'm just going back. So we've already looked at lspgen options. It has the syntax and how to generate it, and the ISIS config file which references all that. Now, how do I start rtbricks? Is first of all, before starting rtbricks, I'm checking the adjacency on the Juniper. I don't have an adjacency. Now I'm going to start rtbricks. bng blaster-c is the config file. Run.socks is to give me an access to the API to check the ISIS status. -i is an interactive mode. So there is a GitHub page for rtbricks that talks about all these options, and all the commands that I'm displaying here is also mentioned there. This is just to demonstrate how it works in action. So please refer to the GitHub page for rtbricks, bng blaster. I will paste the URL for that link in the description also. Now once you start it, so this right now I have started rtbricks. You can see I was having one stream for 1000 packets, and that stream is also working now. As you can see here, it says stream, and 1000 packets are coming in and going out. Now let me check if my ISIS is up from Juniper to rtbricks. You can see the ISIS is up. The host name is also there. So if I look show ISIS adjacency, let's check the database detail. You can see all the routes are there. So there are 5 nodes as we discussed: node 1, node 2, node 3, node 4, and node 5. So all of them have the routes with their corresponding metrics. Of course, you can scale your your flooding information if you want. I have one more window to the rtbrick. So if you want massive number of routes, you just have to put it here with the number of nodes. You can play with this with the number of count. So if you put count as 1000, you're going to have those many prefixes. So it's all manipulative, and you can get a lot of information or flood lot of routing information to the router for scaling, testing, or any other purposes. Now once you've done all this and your ISIS is running, you can run these commands to check the status of your adjacency. So you can see on the rtbricks, it's even telling me that it is this interface, the adjacency is up towards Juniper, the system ID, and the corresponding parameters. I'm logging into the sudo, so it'll be easy to run these commands. This is an API that rtbricks is available, so you can even check the database. You can see all the database information is also available here. Self means what the rtbricks is originating. So I haven't received any other updates from the Juniper because it only has one session towards the rtbricks. That is why your database is only showing all the information that the rtbricks has generated. Finally, you can also check stream summary, because if you remember in the configuration of ISIS, the ISIS file that I was running, I have a stream, right? So every stream will generate a flow ID. So when you do this command, the stream summary, you can run this command, bng blaster, which is an API, stream summary. It's telling me that this is the stream that is actively running. So now on the router, I can even check if I have the traffic working fine or not. So you can see the traffic is in and out. So ISIS is scaling and working fine. So if I do show route summary, I have 19 routes that includes all combinations, right? Because we have the link local, we have the node addresses, and the external addresses. So another option to check it is show route protocol ISIS. So I have all my routes here. So hope you like this video. Bye for now.